So let's start with amines now, coming to the preparation of amines. Okay, so this is the ninth chapter of class 12 chemistry. So preparation of amines, when we come to the first method, is reduction of nitro compounds. Okay, let us zoom in. Yeah, so the first method is reduction of nitro compounds. Now what do you mean by nitro group? Nitro group is NO2 group. Okay, so reducing this group we will get NH2. Now what do you mean by reduction? Adding of hydrogen, right? So removing these two oxygens and adding two hydrogen is the simple change that we can do here. Okay, so what is this Ra? It is reducing agents. Now what reducing agents can be used? Here we can use tin plus HCl, iron plus HCl, which is considered the best method, and H2, that is hydrogen molecule, plus nickel, platinum, or palladium. Okay, coming to the second one, ammonolysis of alkyl halide. Now what do you mean by alkyl halide? It is RX. Okay, R is alkyl, X is halide, right? So this is my ammonia. Okay, NH3 is ammonia. When it reacts with alkyl halide, this R gets attached to nitrogen. Okay, we will write and see. Yeah, so this R, it gets attached to nitrogen. Okay, taking one hydrogen, X will go off. Means what? Here R will get attached, this hydrogen will become 2 plus HX. Okay, one will become one hydrogen, the X will take it off. Okay, HX. Yeah, similarly here. Okay, this is the same thing that we said, right? This becomes RH2. Here again, R will go and join with the nitrogen. Okay, it will go to nitrogen. I'll just write it properly. Yeah, so R will go with nitrogen. R part will go with nitrogen, X part will take one hydrogen and leave. So R NH R. Again, here R part will go to the nitrogen, X will take this hydrogen and leave. Okay. Now the twist is, you will ask me, what if here if I add RX? Okay, because there is no hydrogen to take X, right? That X can take. But here again R will get attached to N. Yes. So here again R will get attached to N, and this will form quaternary ammonium salt. So this is my quaternary ammonium salt, as you can see, which is R4N plus, right? N plus. So next, coming to the next method here, that is reduction of nitriles. Again reduction means what? Addition of hydrogen, right? So this is a very simple process. See, we have, this is nitrile, right? R triple bond, RC triple bond N. This is nitrile group. Okay, so here what is happening? RC triple bond N will change to RCH2 NH2. Simple change. See, break a bond, add H here, add H here. Break the next bond, add H, one more H over here, and add one more H over here. As simple as that. What you have? You have one bond between C and N. Okay, one bond between C and N. You have CH2, you have CH2, perfect. You have NH2, you have NH2, perfect. Okay, so this is the reduction of nitriles, wherein here the reducing agents used are again H2 plus nickel, and the second one you can use is Na into NaHg in presence of this ethyl alcohol, and the third one can be used as LiAlH4. Okay, lithium aluminium hydroxide. Yeah, so the next thing we are going to do is reduction of amides. Again reduction, again addition of hydrogen. Okay, so what is going to happen is, here what will happen? See, reduction also means removal of oxygen, right? So remove this oxygen. Okay, remove this oxygen, add two hydrogens to the carbon. That's all. Done. Okay, because we are removing these two bonds, right, with oxygen. So I'm adding two hydrogens. That's it. First react with LiAlH4, then react with 2H2, then react with H2O, right? Water. Okay, first LiAlH4 and then water. Okay, it will give me my amide. Next method, we come to, yeah, so this is a super important one, which is Gabriel thalamide synthesis. Okay, so this is very simple but also very, very important. Okay, yeah. So when we come to Gabriel thalamide synthesis, so this is my thalamide. Okay, this is my thalamide. Okay, and when I react this first with KOH, okay, potassium hydroxide, what will happen? Water will go off, HOH, okay, H2O together, water will go off, K will stick to N. Okay, we have K, N minus K plus. Okay, only that is the change in the entire molecule, the other things are same. Then coming to this, I am reacting with alkyl halide. So the first step was KOH, second step is alkyl halide. Okay, so this alkyl halide, what it will do here, again see what is happening. Of course my halide is more electronegative, halogens are more electronegative, right? Halogens like chlorine, fluorine are more electronegative, and they will have partial negative charge, right? They have partial negative charge with them, while halides have partial negative, and this alkyl group has a partial positive charge in it, right? So this is alkyl having partial positive. So what is that? N is minus, right? Of course, minus and plus, unlike force attract, right? And again, halogen is minus. So halogen will go and stick to potassium, which is plus. Okay. So the change here is K and X will go off. The only left thing will be this Nr. Okay, other the entire molecule is same, as you can see, only this part we are playing with. Okay, then we have, then we'll react it with NaOH. Okay, aqueous NaOH we are going to react it with. Okay, when we react this with aqueous NaOH, we get a molecule with ONA attached. Okay, now these two are not joined to the same thing, these two are attached to different things, as you can see, right? ONA. And our final thing for which we did all this synthesis is this RNH2. Please don't forget to write this RNH2, because the whole synthesis was done to find or to get this RNH2 itself. Okay, so this was our Gabriel thalamide synthesis. I'll just erase once all these things so that we can just have a clear look on it once more. Yeah, so of course the first process, as we saw, the first process was reaction with KOH, second process alkyl halide, third process NaOH. That's all. Okay, Gabriel thalamide synthesis done. Then Hoffman bromamide degradation reaction. Okay, there are a few named reactions, but they are very easy. Okay, so Hoffman bromamide. Bromamide gives us a hint, we need bromine, right? And degradation reaction. So here what is happening? See. So this is my R C double bond O NH2 amide. Okay. So according to this, we must have a bromine and an amide, right? Bromamide, bromine, amide. This is my amide. Okay, reacting these two with 4 moles of NaOH, we will get RNH2, for which with these we did all these things, plus Na2CO3 plus NaBr plus 2H2O. So let's simplify this. See what is happening here. We have this thing known as amide, right? This thing known as amide that we have. This is our bromine, as we know, and this is our NaOH. Okay, we have 4 moles of NaOH. So the first thing we got is our RNH2. Okay, so we wanted this only, so we did all these processes. Okay, so first let's write RNH2. Okay, now R is done, NH2 is done. Now whatever is remaining in this, what is remaining? Na is remaining. Okay, how many Na are there? Total 4 sodiums are there, right? If you want to balance the reaction, right, we have 4 sodiums. So we will take 2 sodiums with this CO group, and we can also take one more oxygen from this. Okay, so we'll get Na2CO3, and the leftover is what? Again 2 molecules, 2 moles of sodium is left, so 2 Na, and of course Br2 NaBr has to be formed, right? So NaBr salt will be formed, and the leftover is H2, 2H2. Okay, so a simple division of these. Okay, to just remember what all we formed. Okay, so the first thing of course will be RNH2. Then coming to the next thing. Okay, so with this we are done with the preparation. Okay, these 6 methods were the preparation. Okay, next coming to the chemical properties of amines. Okay, so the chemical properties are firstly basic character, alkylation, then we have acylation. Okay, in that these two reactions are there, and then we have carbylamine reaction and reaction with sulfonyl chloride. Okay, very easy. We'll have a look at these things as well. So coming to the basic character, amines react with acids to form salts. Means what? Amines are basic in nature, right? So this is an amine. It reacts with an acid. For example, HCl, right? Cl is this halogen. So it will give me a salt, which is RNH3 plus X minus, right? Here if I have aniline, okay, so aniline plus HCl, it will give us anilinium chloride. As you can see, the only difference is here it was alkyl group, here it is aryl group, right? Benzene ring attached group. So this is again a reversible reaction, okay, super important. So it will give us anilinium chloride. Now amine salts on treatment with base, okay, NaOH, regenerate the parent amine. See what we did here, we got a salt, right? Amine salt. What we did, we reacted amine with an acid to get amine salt. So now I will do the ulta process. Means what? We have the salt, we'll react it with a base so that we can get our amine back, right? So that RNH3 plus X minus plus OH minus. Okay, OH minus comes from base, right? Will give us RNH2, which is our amine back, plus H2O plus X minus. Okay, now behave as Lewis bases. Yeah, so these RNH2 behave as Lewis bases due to the presence of unpaired electrons, as you can see, right? They behave as Lewis bases. Now, amine salts are soluble in water, and of course, the basic character is directly proportional to plus M and plus I effect. Very, very important. Basic character is directly proportional to plus M and plus I effect. Okay, or plus I groups. And it is inversely proportional to minus M and minus I group, while acidic character is ulta. Okay, here we have basic character, so let's go with it. That is plus M and plus I. Okay, so if I talk about an example over here, aliphatic amines are more basic than NH3, which are more basic than aromatic amines. So what is aliphatic amine? When I talk about it, is RNH2 group, right? So this RNH2 group is more basic than NH3, which is again more basic than any aromatic amine. Okay, benzene ring attached amine. Okay, why? Because this CH3, this aliphatic group or alkyl group, is a plus I group, so it is more basic, and NH3 has no such groups, okay, medium. But again, this aromatic amine, this benzene ring, is a minus I group, so it will be less basic. Okay, coming to the second one, which is alkylation. Okay, as per the name only we can get, right, alkylation. So RNH2 plus alkyl halide, again RX. Okay, it will give us, okay, the same process again, R NRH, okay, plus HX, again reacting with RX, it will give us a tertiary amine, right? This is a primary amine, RNH2. Secondary amine is 2 Rs and NH, secondary. 3 Rs is tertiary. Quaternary is what? 4 Rs. But here there is a twist, C. Here we have R plus and N plus and RX minus. Where is the twist? I just encircle it. Yeah, so this part, okay, this part is the twist over here. As you can see, N plus Rx minus. Okay, yeah, I just erase it. Then we have the next reaction. Yeah, then we have the next reaction of, where is the third one? Yeah, this one. Acylation. Alkylation done, acylation. Acylation is when we react an amine with acid chloride. Okay, so let's take this R to be C2H5. Okay, let's take an example, C2H5NH2. Okay, let the example be C2H5NH2. Okay, NH2. Okay, C2H5NH2. When I react this C2H5NH2 with an acid chloride, okay, an acid chloride, then what happens here? This, see, this lone pair of electrons or this double bond character is shifted to oxygen. Okay, double bond character shifted to oxygen means what? Electron pair is shifted to oxygen, right? Lone pair of electrons shifted to oxygen. So when electrons are shifted, oxygen will get a negative charge, right? Oxygen becomes negative, and here will be only a single bond, right? So what happens? And this, it has a lone pair of electrons, nitrogen, so it will come and get bonded to carbon. So what will happen here? This is our reaction over here. See, nitrogen bonded to carbon, oxygen with a minus charge, it stays with a single bond. Now what will happen? This chlorine will be removed with one hydrogen from here. So we'll finally get CH3 C double bond O NHC2H5, which is an amide, okay, plus HCl. Okay, now coming to, we can, if we have aryl ones, okay, if we have aryl amines, so what will happen in case of aryl amines over here? As you can see, NH2, again the nitrogen will go and get bonded to carbon, oxygen again it will have a minus charge, right? So similarly again Cl will go off with one hydrogen. Okay, we will get again an aryl amide over here, right? This is an aryl group, right? So CH3 C double bond O NH with an aryl group, okay, benzene ring plus HCl. Then coming to the fourth one, okay, this is an important reaction, a named reaction again, carbyl amine reaction. Okay, so again we have our amine over here. Okay, amine we have, then we have CHCl3. Okay, we have CHCl3 plus 3KOH. If we heat this, we get an isocyanide, that is RNC, plus 3KCl and 3H2O. So this process, carbyl amine test or carbyl amine reaction, is also known as isocyanide test. Why? Because isocyanide is formed. Okay, and this test or this reaction is only and only shown by primary amines. Okay, super important point. Then coming to reaction with aryl sulfonyl chloride. Okay, when we come to aryl sulfonyl chloride, this is our Hinsberg reagent. Okay, aryl sulfonyl chloride. This is our Hinsberg reagent. Okay, so this Hinsberg reagent, when we talk about, as you can see, benzene ring with S double bond O groups and a Cl group on the top. Okay, so this is reacting with C2H5NH2, right? C2H5NH2, and it gives us a benzene ring with S. Okay, SO2 groups remain the same. Only the Cl is replaced by NHC2H5. Why NH? Because again one H is taken by Cl. Okay, when we, yeah, so out of these two H, one H is taken by Cl to form HCl, right? And the remaining is what? Only NH, right? So this C2H5NH goes and gets attached to this sulfur. Okay, now this benzene sulfonyl chloride is also known as Hinsberg reagent. Now this is a very important test again because it gives us the differentiation. Okay, let me write it down. It helps us to differentiate between primary, secondary, and tertiary amines. Now, how this Hinsberg reagent, it is giving me a product over here, right? So this is first of all what? It is a primary amine, right? It is a primary amine. So when I react this Hinsberg reagent with a primary amine, it gives me a compound which is soluble in alkali, which is soluble in alkali. Okay, it is soluble in alkali. But then when I talk about if it reacts with a secondary amine, okay, if this Hinsberg reagent reacts with a secondary amine, okay, then it will give me a product which is insoluble in alkali. Okay, yeah, so it is insoluble in alkali. When this Hinsberg reagent acts with a secondary amine, it is a product formed which is insoluble in alkali, and there is no change in the reaction. See, the only thing is, for example, if I react this Hinsberg reagent with C2H5 twice, okay, that is R2NH, right? C2H5 twice NH, which is a secondary amine, right? It will give me almost the same product, okay, the same steps, okay, with S double bond O. Okay, this side, that side also double bond O we have, and up. The only thing here is what will happen, we'll again get the same thing, that is C2H5 on one side, one more C2H5 only, and we'll not have any H over here. Okay, because compulsorily chlorine will take one hydrogen from nitrogen, and here it has only one hydrogen, right? So I will get N C2H5, that is my ethyl group, right? Or I'll just write it properly. So we will get C2H5, yeah, C2H5, and even this side the one more C2H5. Okay, so for primary, this is insoluble in alkali. Okay, super important, this is insoluble in an alkali. Okay, so with this we are here done with the chemical properties also of amines. So coming to now the next thing, which is electrophilic substitution. Yeah, in chemical properties we are still left with electrophilic substitution. Yeah, so here what do we have? We have, let's zoom it. Yeah, so in electrophilic substitution, first Br2, that is bromine water, in presence of H2 or any other polar solvent, we get 2,4,6 tribromoaniline. Okay, as you can see, if CCl4 is there or any other non-polar solvent is there, then we will get ortho and para bromoaniline. Okay, this is ortho bromoaniline, this is para bromoaniline, right? And here concentrated HNO2 in presence of concentrated H2SO4 or doing nitration, okay, at 288 Kelvin, we get three products. Here we get ortho, meta, and para products. This is a super important biggest change, right? Ortho, meta, and para products. Wherein ortho product is formed 2%, meta is formed 47%, and para is formed 51%. Okay, and concentrated H2SO4, if we react aniline with concentrated H2SO4, we get anilinium hydrogen sulfate. Okay, as you can see here, we get anilinium hydrogen sulfate. Further reactions with concentrated H2SO4 will give us sulfanilic acid. Okay, NH2 up, and on the para position we have SO3H group. Okay, this can also be, reversible reaction, in the form of reversible reaction. It can form NH3 plus and SO3 minus. Okay, just the H has went up. Okay, so this is known as a Zwitter ion. Okay, this is known as a Zwitter ion. Important. Now coming to aniline reactions with CH3CO twice O in presence of pyridine. Then what will happen? This we will have, of course, we have already have NH2, right? You already have NH2 in aniline. So here what will happen? NHCOCH3 will get joined here. Okay, so let me draw aniline over here. Yeah, so when this aniline, okay, yeah, when this aniline reacts with this, it will give acetanilide. How? See, the only change over here is remove one hydrogen, add this COCH3 group, acetanilide. Okay, again this on reaction with HNO3 and H2SO4 into 88 Kelvin, we will get P nitroacetanilide. Okay, and reaction with OH minus or H plus, we will get nitroaniline. P nitroaniline. Okay, so this is para nitroaniline. Okay, yeah. So now coming to the next thing. Yeah, before that, yeah, see, this is HNO3 and H2SO4 at 288 Kelvin. Yeah, nitration always occurs for aniline in presence of HNO3, of course. Yeah, so this is HNO3. Yeah, so coming to the next thing now, that is diazonium salts. Okay, so diazonium salts, when we talk about, we'll zoom out. Yeah, so diazonium salts, when we talk about, so the first thing, this, the phenol, the benzene ring with NH2, which is aniline, on reaction with NaNO2 plus HCl in the presence of 0 to 5 degrees Celsius temperature gives benzene diazonium chloride salt, right? This is the salt. Okay, wherever pH is written, it's just a benzene ring. Okay, yeah, so on reaction with Cu2Cl2 plus HCl, we get chlorobenzene, Cu2Br2 plus HBr, we get bromobenzene, and CuCN or KCN, we get cyanobenzene, right? And We have here coupling reactions. Okay, let's zoom in. Yeah, so these coupling reactions, when we talk about, first reaction is electrophilic substitution reaction. Of course, these two are electrophilic substitution reactions. Okay, so what is happening? See, this is my aniline. Okay, so when this diazonium chloride reacts with aniline, then what happens? It forms a product called p amino azobenzene, which is para amino azobenzene. Means what? See, these two benzene rings join together. The only difference is these both nitrogens are joined with a double bond. Okay, yeah. So then the next is, when this reacts with phenol, diazonium salt phenol. Okay, reacts with phenol. So the only change is, instead of this NH2, we'll get a OH over there, and the name here will be para hydroxyazobenzene, wherein amino azobenzene, para amino azobenzene is a yellow color dye, and a para hydroxyazobenzene is an orange color dye. Okay, now coming to HbF4. Okay, when we come to HbF4, we have N2 plus Bf4 minus, right? When this diazonium salt reacts with HbF4, it will get N2 plus Bf4 minus attached to the benzene ring, and after reacting with NaNO2, copper and heat, we will get nitrobenzene. Okay, then reaction of this diazonium salt with water gives us phenol. Okay, then reaction with ethanol gives us benzene plus N2 plus CH3CHO plus HCl. Okay, then coming to reaction with H3PO2 plus H2O, which will gives us again a benzene ring, and N2 plus H3PO3 plus HCl. So yeah, then we have reaction with Ki gives us iodobenzene. Reaction with HbF4, as we saw, it will give us benzene ring with N2 plus and Bf4 minus. But this only on heating, it will give us fluorobenzene plus Bf3 plus N2, which is Bals-Schiemann reaction. Okay, there we added NaNO2 and Cu as well to form nitrobenzene. Here we are just heating it to form fluorobenzene. Okay, so these were the reactions of diazonium salts, as you can see. So the notes will be sent through the telegram channel with this correction as well. Okay, thank you.